initiated like last year capital improvement project. This capital improvement project is looking at rerunning or reanalyzing those areas of concern, and then identifying those additional detection that is needed, and also incorporating that additional detection into the system. Part of that is reviewing the assumptions of the original for those areas, possibly having to redefine source term as appropriate, and then doing the analysis or utilizing a subject matter expert outside of our organization, and also using it as an opportunity for development of our safety engineers. We'll talk about that later. In building our external resources. We would like to state that in performing the necessary analysis, what we have identified is that back in 2011, 2012 timeframe, the scale model that we use has been upgraded, and utilizing the upgraded scale model is taking an extended time for computing. So an average model run now is taking about 18 days to get information back, and then have to go back in and adjust as necessary, and we run it differently. So to date, we would like to state and share where we are with our current state in the plant. Autoclave was the area in which this condition was initially identified. Through our reanalysis process, additional detection is not required. Our current system, and as was conditioned in October, could pick that up. However, working through the other areas that were identified in the extended condition, additional detection was noted as being required in the reanalysis. So if we look through there, we have 5 areas: autoclave, mill, final clean, pickle, and UT. Those 5 areas, the reanalysis as of this week has been completed. Facility mods have also been completed, in which 12 detectors were added to the system, and compensatory measures have been placed. So adding those detectors to the system does require plant shutdown and evacuation of non-primary individual in relationship to it. So it does take the facility to come to a safe shutdown, fuel handling deceased. We have to take the system offline, make the additions, and then test them, and everything recommission that we need. Looking forward, we have water volume. That analysis will start on, has already started on, and we're hoping to finish that up shortly. And then we'll move to our waste treatment areas. It's the low level radiation retention tanks and the utilization tanks for our waste treatment process. We focus on areas in which employees had more likelihood where our waste treatment is segregated to a lower plant population. So that's how the prioritization of that. Right now, we're looking at a project completion date of August of 2025, a year from now. And again, that has to do with significant run times and also coordination of resources and corrective. We are optimistic, though, that we can pull that date in, acquire additional computing power, and are working to bring that online. We're going to run some more areas in parallel versus one area at a time.
Where do you leave that? I mean, and this may or may not be relevant, and I'm going to state it simply, just for my own better thinking about this is that this. For the original area for which you reported and started us down this path, you've done an analysis and now said that configuration as it stands meets the regulation. However, as part of your extended condition, you identified additional areas for which you needed to, that did not meet the regulation, and if you needed to meet or make modifications. And I'm sorry for the oversimplification.
No.
I just want to make that thing.
No, that's perfect. Yes, the original report, my terms could be retracted and pick up her phone the next day. So Correct.
Right, but it's all part of.
It's all part of
to
the-
Get your extent to did that work.
I think it's also worth pointing out, Laura, that the way we did this to be able to get to a point that as we completed the analyses, the mods were already done. As the work was in progress for the placement calculations, we brought the subject matter expert on, we used our grid safety engineers, walked out and came up with the optimized locations based on what we knew so far, and also considering the equipment in the area. So we went ahead and put the mods in. So there's an extra set of detectors in the autoclave, assuming the calculation wasn't going to work. So there's extra overlap there now that we put in just because of the approach we took to try to get the work done in parallel.
Alright.
So during our investigation, it was identified that our engineering department utilizes a design review process or procedure. Also utilizes a tool called potential problem analysis, and it's utilized to firstly challenge assumptions during the design process. These types of tools were not utilized during the initial detector modeling back in 2011. So we've developed a procedure for project leadership, established from complex versus kind NCS analysis we utilize. And this procedure actually takes into assessing skills required for the specific project or task at hand, comparing them to the experience of the engineers that will be performing it, and peer review, and peer reviewer as well. Further, it encourages benchmarking with other organizations and subject matter experts outside of NRGL. Then also establishes periodic team meetings that are designed and with the intent of fostering skeptical thinking while discussing the design and analysis or base assumptions and parameters that are utilized as the project begins. This procedure that has been put in place, and we are actually currently utilizing it now. We're utilizing it for the criticality accident alarm system upgrade project that's occurring at our Lynchburg Technology Center. Apart from this issue, we're updating the system as well due to the stage and things of that nature. So utilizing this summer and continuing to utilize that for the periodic team meetings appropriate for as we work with that project. We've also identified future projects that are on BWXT's radar that will require first of the kind analysis for our current staff of grid engineers. The Molly casting project that's coming up in the next few years, and then also the project that will be coming to us in the next years.
Before we move on, so I have two questions. The first one is, so you're implementing the new process now in the upgrade for the FTC. Any insights that you can share that's been going?
William, any insights to share? I have something to go.
So we have identified some similar large volume wastewater tanks in the LTC for low level rat waste that represent similar concerns to the waste stream data that we've identified inside of NRGF. And so we have been working towards resolving plans prior to the analysis being completed. I believe in the departments.
Okay. Well, I think from the structure of it as well, from my perspective as a management leadership periodic updates, I wasn't around when we did the 2011, 2012 upgrade, but it's something that I get periodic updates through my staff meetings about what some of the challenges are that we're working through on that project as a special project as well. So there's greater awareness of what's going on, and we can think about alternative means to help address how we're going to work through some of these issues and what resources can we pull in from other parts of the company if we need it, and share that discussion with the grid safety engineers at the NFS as well as here. So we bring in that where you find challenges or where you find blocks, we can bring additional resources from across the company to help us or outside of the company.
Thanks. Then the second question. So the creation of this analysis is a first of all kind of activity. And that happened when you were operating the system, and that happened 11 years ago. In the meantime, every time that you had to put new detectors, what was the process? Did you get an opportunity to revise the analysis or the assumptions, or you took the analysis for granted for placement?
Whenever we add or relocate detectors to our system, we would revise that analysis. Up until I joined the company, those revisions were handled by one person. And since I joined the company, including myself, other members of our group have taken more for it.
A lot of, we'll say plant modifications that occur in our facility, machine moves or installation of a light con machine. At source, the modeling for our shop floor area, the source term and everything, we did go back and look at that back in October and are confident having the question doing the assumption that we're within. I think this was looking at vessels in which contain water, and the water, the vessel, and the fact that all of them, the majority of the process operations, autoclave and deal people that we're talking about, they're below subgrade. Go ahead.
Right. Just to follow up, when did you join the company? When did this transition?
I joined the company in late 21.
In addition to reanalyzing those identified areas, we're reviewing all the inputs. I think this goes to a good question, Lamar. Of the original past analysis that was completed in 2012, the review is ongoing now in parallel to the reanalysis. And looking at it, we did take a quick view of the majority of our operations where they had shop for machine type. It says a completion target of the year next year. We're resource limited. We're focusing on, operational plant safety, getting the mods in place now, and continue to parallel these two efforts that we're discussing. We're also reviewing Chapter 5, the SNM 42, the requirements that have infrequent NCS involvement or may have been performed by a single individual, single contributor. We have identified that our NCS validation documents and processes are something in which are infrequently updated, and are currently reviewing that as well to see if there is anything which inadequate interpretation may have occurred within assumptions or within. We are also continuing the process analysis project or PA project, which we've been working on for a few years of consolidating nuclear safety, nuclear fatality safety evaluations, and comparing them together in one rep control document for its associated process. And lastly, as I said, we look at corrective actions and people. We know that people are our greatest resource, and in order for us to continue and develop, we have to develop them, their capability, their knowledge, and their knowledge transfer as well from one individual to another. We recognize that NCS engineers are highly sought in the industry that we're in, the fuel cycle industry. But furthermore, those individuals with the knowledge and the experience with gas detection or neutron transport modeling are even fewer and farther between. So we have enhanced our structured only job training and qualification requirements for our NCS engineers. Our qualification requirements that we have in place today now require familiarity with the difference between dose rate or neutron transport modeling that's utilized for gas analysis versus the methods utilized for normal NCS's nuclear criticality safety evaluations and processes. We've incorporated lessons learned from this incident into our training and qualification regimens program. And then we require reading and understanding of the guidelines and the policy that we put in place for the first of the kind NCS analysis as well. And as we continue to work through that, Omar, I think the question is, if we utilize our process, we're going to find areas for improvement and rev it and change it, bring those lessons learned in, as well as we get operational experience with that. Furthermore, we're committed to developing our internal capabilities and our internal NCS staff. This year, 2 employees have completed ONR scale criticality safety and radiation shielding course, and which utilizes neutron transport modeling and things that requires course application and pass reanalysis. Again, William has voluntarily stepped up to take on the learn the intricacies of pass analysis and getting practical application under the guidance of the industry SME as we work through the analysis of these disparities. Practical application while working at some. So with going through our corrective actions, I get the presentation to Rich.
A couple slides, I'm going to talk a little bit about enforcement perspective and some comments relative to safety significance for your consideration. So first, enforcement process. The circumstances of this issue seem to align me with violations that I've been involved with dealing with old design basis issues. And I know that's under the power reactor side, but I think the philosophy is something that's worth discussing. So one of these is to address the issue was identified by the result of it started off as a voluntary initiative. That's the criteria, is that it be a voluntary initiative. We did start the PA process off as an initiative prior to a previous enforcement matter that occurred in 2017, and then was committed to in 2018 as part of that enforcement process to continue the PA process. So recognizing that that's where we are relative to whether it's a voluntary initiative or a regulatory induced initiative. I think it's worth recognizing as well that this is a large complex analysis we're doing. The contracted resources alone that we spent over that time period is over $6 million to be committed to this project. And this is the first case where we've had to come into an enforcement setting for anything that we found out of the PA process. We're about 50% complete of the total scope of the work that we intend to do under that project. The next criteria is it was or will be corrected, including immediate corrective action and long-term comprehensive corrective action for non-recurrence within a reasonable time. We've described our corrective actions from the three perspectives as currently in process that Daniel talked through, and the modifications. I would say that was the easiest capital project improvement I've ever gotten done. Everybody from top to bottom of the organization understands that having a accurately functioning criticality action alarm system is a price of entry into doing the business that we do. And then that we looked at the improvements to our complex first of kind nuclear criticality safety project management processes and additions training qualification to make sure that the changes that we're making and how we're looking at this are sustainable. It was unlikely to be identified by efforts such as normal surveillances or routine scheduled quality assurance activities. Details associated with this assumption that was incorrect, and it was a misinterpretation. You heard the parallel of the language under 7024 for combined neutron and gamma radiation at an unshielded distance of 2 meters from the reacting material. That was a misinterpretation of that language in the conversion of that into the calculation. Yet that level of detail and understanding and seeing how that conversion was made and how it was actually modeled in the system is what we had to find. And so it took somebody purposely looking for something to find this. It wouldn't have been found by any normal mean or any other normal review.
And that's part of my question was getting to that. It's like, if even to the point that during that time period, you had opportunities to install new detectors based on that assumption, that you would have not identified the issue. That is correct.
That's part of why we did the actions to go back and relook at the rest of the calculation and look not only for that assumption, does it apply somewhere else, but are there other assumptions that we've made that may not be valid or a misinterpretation. So that those actions are still in progress, and it's kind of a learning iterative process as we're looking at this and we're learning more and we're looking at the new modeling And we have an outside contractor that's part of the team. We have contract resources and we have internal employees working as a team to work to make these improvements. Making sure they hear any of the slight reinterpretations and we relook at that full set. That's why we're not setting an immediate corrective action date to say, I want that done in 3 months, because there's a lot of learning that's going on with the organization as we're working together to upgrade these criticality safety analysis and upgrade it to a more current state product. The scale calculations now are, we're working through a revision that's several revisions beyond what it was in 2011, 2012.
Okay, thanks for the clarification.
And what you're saying is that language error into the CAPS occurred in the 2011.
2011 timeframe, that's correct.
So that's where you go to the old design. And then what was, and maybe it was even, so I just want to be very clear. What was the voluntary effort? What initiated it and when was that?
So, just an understanding of our configuration management program and how our calculations were set up from a criticality safety perspective. The original process analysis work and a program to go relook at all of our crit safety bases was because the facility had been around for a long time and it was not revision controlled calculation. The calculations were there was a base calculation and you make a change to it, writing an addendum, and there'd be some additional pages. And that happened in sequence so that it became very difficult to go look back and make sure you got it right and applied all the changes back to the original base calc. So the original scope was just to take those calcs, incorporate all the changes and rewrite and have a new base calc. That was started 2014 as an initiative in-house based on, I guess, we get 2 inspections a year. We look at it, we have events, and we have to, every time we have an upset condition from a crit safety perspective, we have to look back to those base calcs to make a decision and a significance determination. So through our own organization, seeing and saying these calcs are difficult to use, feedback from the NRC saying reviewing these is difficult to use, we started that process on our own in 2014. Then we had an event over the 4th of July shutdown in 2017. There was material accumulation in the desiccant dryer and research test reactor area. And as a result of the enforcement coming out of that issue, we committed to continue that project. And so we committed at that time additional resources and started moving faster than had been to that point. And the scope document that's written at that time includes the words that William read about going back and applying judgment and looking at the crit detection system and the modeling crit detection system as part of the scope of that review. So that's why we say it's tied to that process. It's not really tied to the original intent, but it is tied to what we said, the scope of what we said we would do after the 2017 event.
Yeah, if I could just maybe ask a little bit more about that. Were there any other changes in maybe scope or the depth of the looks or resources? And you mentioned real quickly resources committed from the original 2017 effort to the 2017 sort of taking credit for that is correct back.
Right, we took credit for that. We added additional resources, but it's been challenging in the history of when I came into BWXT 3 years ago. Was one of the first things I got up to speed on was how much progress have we made, where are we at? And we were behind the project plan of where we wanted to be. And some of that is resources, even contract resources that you can't keep continuous. So it takes us about 2 years to qualify somebody to be a reviewer because of the way that the process are set up and the level of qualification and the questioning attitude. We want to be able to see that demonstrate through the qualification process. So we had some contractors come in and they do some work and then move back off. So, decide they'd go somewhere else. So we had some challenges relative to staffing there. So we use a combination of contract resources, direct employees, and we've even done some cases where we have employees that are chemical engineer that had worked in research test reactor aerial recovery, knew the processes really well, but weren't crit. We moved them into crit and built our own crit people and done all the training that we need to do to qualify. So we've used the combination of ways to try to keep this program staff, always keeping safe operation of the facility as the highest priority. And then we track our completions, set goals on an annual basis, and track the completions through our safety review committees and report out to management on how the progress we're making. And our priority is really making sure we have a high quality product when we're done. Not so much the timeline and schedule when we finish it, but we're committed to working our way all the way through it.
The breadth and depth of those reviews is the same prior to this 2017. So
I would say
The breadth and depth, yes, the same methodology. The laws were there in 2014 when we got them self-identified to try to change from our CSEs to PA methodology. And doing that, it was as changes come in to current changes to current models and looking at them and working that way. So it was selective and internal resource between and it wasn't going out and looking at the plan as a whole, which we've done for the team. We realized creating timetable and processes that delineate on an annual basis, as we've said. Now we've identified. So in the methodology is the same. Resources were internal and limited efforts. In 2017, 2018 timeframe, to dedicated internal resources and also external, utilizing external resources as well. And speed the timeline of as in working process, not necessarily speeding up the evaluation or the methodology, just putting a project plan in place and working with that plan.
Can you just shed a little light on the 2018, the commitment you made in 2018 for the previous enforcement action? Just at a high level, what was that enforcement action? I don't recall it. And were the root causes for that action in line with, consistent, similar to what the root causes are for for this case here?
so. I'd have to go back and review. I'll give you one number, but I'm going to give you a 90% accuracy because I was working at NFS at the time, and we actually were on the phone supporting the EOC from NFS when the event happened at NHGF. But bottom line, it was a material accumulation event where a ventilation system in our research test reactor area, there was some finely pulverized powdered material that carried over in a filter that had some bypass flow, and it accumulated in a desiccant dryer that was to keep the atmosphere in that glove box dry enough to allow that work to occur. So that accumulated over a period of time. The reason it was a July shutdown, when those 4th of July shutdown, is that's when we do maintenance activities, and maintenance workers had gone in and were disassembling the desiccant dryer, and they found this accumulation of material stop work and activated the EOC, and we were in a condition in an alert for a period of time. So, and the causes of that were much more physical design, physical installation, not design basis analysis. So I don't see a parallelism of the root causes. Same thing wrong there. You guys lived it too. Right.
That,
And
that's why we were.
it's very sensitive.
Yeah.
So bottom line of what I was trying to share from an enforcement perspective is I believe there's provisions in the philosophy of the NRC enforcement policy that encourage licensees to go out and find problems like this that you wouldn't find by other means. And that's what we've been doing. That's what we continue to do. And that's what we're committed to do to continue to work through that. So safety significance, I'm going to say a couple things here that Jim kind of reiterated to start off with, but we recognize the separation of the requirements for criticality action alarm system in a separate standard from the meeting performance criteria and having integrated safety analysis. But it is worth saying, I think, and I'd be amiss if I didn't think we at least included in the discussion that while the criticality accident alarm system would not have detected criticality in these limited locations, it's less than 2% of the area of the facility that we're talking about for the area of the coverage of the system. The likelihood of a criticality accident event hasn't changed or was not affected by this area. So that small area that was affected, most of those areas are, well, all the areas are not normally occupied. Most of them require permission before you enter those areas and the issuance of a key to be able to get that from the frontline manager of the area. So had there been a criticality, it's in those areas and the alarm hadn't gone off, we still would have been able to retrieve people back in those areas. And part of what goes into that, the occupied areas that are adjacent is where the detectors are. So where the people are is where the detectors are. And there's inherent shielding. The same shielding that's preventing us from detecting the minimum accident of concern is also shielding the dose to the individuals in the area. So that's kind of some softer stuff around the consideration of significance. But there's one other piece, just try to put it in perspective relative to the minimum accident concern. When we calculate that, take the minimum accident concern and change it into a fission yield and try to put it into more common language to understand. That's on the order of 10 to the 14th fissions. When we look at all of the reported using operating experience from what's occurred out throughout the world for actual criticality actions, all 22 reported criticality actions had yields of greater than 10 to the 15th for fission. So that's an order of magnitude higher. Nearly all, except for one or two, had criticality accidents had yields of 10 to the 17th fission. There's another couple order of magnitudes higher. So when we were doing the calculations, particularly like the area that we started off with autoclave, we not only looked at where can we optimize placement of new detectors, but would the existing detectors have worked? And we did some sensitivity reviews based on that data as we were upgrading and understanding that data. And it showed that we likely would have, for the historical operating experience, all of them at the level of 10 to 15 fissions, we likely would have identified it and gone into a line for all those cases. So although we clearly didn't meet the regulation, and I'm not trying to argue that, and it's a compliance issue, we're just trying to put significance on there. If it had been what typically had been seen through previous criticality accidents, we're confident that this system would have belonged. So that's kind of concludes our comments and things that we want to share on our perspective. We'll go back to Jim.
Yes, I'll just kind of close out. So in closing, we appreciate the opportunity today to share our perspective regarding the proposed enforcement action. We do recognize the significance of the issue and are committed to improving our operations, improving the skill basis in which we operate, and the oversight of complex analysis like the ones we talked about today. We hope that sufficient information has been presented to provide a better understanding of the facts, root causes, and corrective actions associated with our criticality accident alarm system. We also hope that our perspective on these matters will be taken into consideration in your deliberation and the application of discretion will be applied relative to making enforcement and civil penalty decisions. So we thank you very much for the dialogue today. If there's any further questions, we'd be glad to answer.
Great. Thank you very much for your presentation. Before we do take a break, I want to go to everyone in the room, see if there's any questions, and I want to check with our colleagues who are joining us remotely to see if they have any questions before we take our topics. So let me just go around.
No.
I know, and I do appreciate asking questions for going along that. Sorry.
I did have one. So just in terms of your immediate corrective actions, there was some discussion about timing and the completion of the calculations, I think. The report was on October 17th. It sounded like it took some time to go through the analysis to convince yourself that it may not have been meeting regulatory requirements. When you initially, the thing I'm missing is when you initially thought you might have a problem through the October 17th report, were there compensatory actions sort of put into place while you were in this sort of gray area? You weren't sure whether or not you meet the regulatory requirements. So, so you talked about EVs, the 50 mile per hour. What was this sort of status of any sort of?
Yeah, so I'll take that one. Yeah, because I was directly engaged with it and I'm hearing what was coming out of Fritz. When it first came up, it came up as a question. When we looked at, said, okay, what's the worst case that happens if we don't meet it? Here's the timeline. It's a reporting requirement, how fast we have to report it. So we said we need to move through this in a timeline that's consistent with that reporting requirement. So that gives us a basis for here's a safety basis for how much time we should spend looking at this. And quite honestly, we were closer on the autoclave area that it looked like it may work when we remodel it. And then when we started doing extended condition and we looked at some of the other areas, we recognized that it wasn't as close to being successful. And we could try to go do all these and look at more, but we realized we had a bigger problem. And so it kind of evolved over 2 or 3 days. And it was a decision basically at my level to try to keep the pressure off the grid engineers from trying to go too fast to do the calculations, but to give them a little bit of time to work our way through it and have daily interchanges to say, okay, we're not going to get there from here. Let's just report it. So there were no interim compensatory measures while we had a question in the air. When we made a decision that we weren't going to get here from there, the decision wasn't to go put comp measures in place. The decision was to shut the facilities down. And so we had some discussion along the lines of this may not go good. So let's not start any new runs that are going to be long duration runs that could cause a quality problem if we need to shut them down. So, some of the pickle processes, some of the other processes go on for 2 or 3 days. And we chose not to start new components, but into those if it went bad. And we just kind of set a line to Sam, we need to make a decision by this date, and then we'll go forward with it and we'll shut down, because to get the comp measures in place, the amount of training and communication and making people comfortable with, we're talking about the grid protection system here, and a lot of what we've talked about significance and that the probability of an accident hasn't changed. We had a lot of discussions with the workers on the floor and a lot of interaction with people that we were asking to do some of this monitoring before we asked them to do it, so that we would maintain like safe culture.
Yeah, thanks.
Does that help?
Yes, it does. Okay.
That's been inspected, I know. Yeah.
Other questions? So may I ask our colleagues on Teams, let's see if I can first them y'all and James, do you have any questions before we go to caucus?
No questions.
All right. So I want to thank you for your presentation. I do appreciate it. I appreciate you entertaining questions through and things like that. We're going to take a break to have a quick internal meeting to discuss the information you presented in this. And then we're going to determine if we have any additional points we want to talk about or if we want to pursue. For members of the public who are attending via Microsoft Teams or phone, please remain connected and we will resume the meeting momentarily. It's probably 15 to 20 minutes. So what I'm going to ask, it's 11:05. Where are we meeting?
Next door.
Okay, so I'm going to ask, I would say, let's start our meeting at 11:10 so that everyone can take a bio break, and we're going to leave someone in the room to
Yes.
allow these folks to use the restroom and or escort. So if we say 11:10, let's say we'll be back online at 11:30 here for this meeting, and we could be back sooner than that, but we'll just set that time for it. Good? Turn it to Joel, make sure I didn't do anything wrong.
Nope.